computers and life has been revolutionized. Thanks to technology, which we are taking up every day, everything around us has changed. Since the time bioinformatics took over and artificial intelligence took over, I think this is the crux of the matter. Welcome everybody to the session on Bioinformatics Future Career and Scope. I'm your host of the Margdarshika series, Shekhar Suman. And today I have a special guest for all of you. Computers have truly revolutionized the way we communicate, interact, and do research. And truly speaking, it would not have been possible without the advancements which the IT field did. But today, it's merging with biotechnology, biosciences. Welcome, everybody. I hope you all can hear me. Can you guys quickly say hi in chat? Hello, everyone. Can you hear me? Welcome to the session, guys. Welcome, everybody. Welcome to the session. My name is Shekhar Suman. I'm the CEO and Managing Director at Biotechnica. And today I have a special guest who is going to talk a lot in detail for the first time live here at Biotechnica, and that's none other than our very own Dr. Farhan Zamir sir. He'll be joining you in the next 5 minutes or so. But before we get started, here is a powerful message for all of you. Just before this session started, I was interacting with sir, and I asked, sir, what do you think is the power of bioinformatics? And he said, 10 to the power infinity square. That's the power of bioinformatics. It's something which is expendable, scalable, and in future will make a lot of money for anyone who learns it, because it allows your biology to merge with computers. So you grow at the speed of computers, but you analyze biology. You stay a biotechnologist, but you use computers. And with the advent of AI and quantum computing, like I told you in the last session of Margdarshika series, that the first one which we did on Monday, it is going to revolutionize. Okay, so welcome Loga Lakshmi, Bhumika, Rohit, Lakshmi, Deepthi, and everybody. Thank you so much for joining for this session. We really wanted to do it at 7 o'clock, but as you know, Farhan Zamir sir is busy with the Chem Informatics internship he's running right now, and that goes on till 8 o'clock, okay? Because there'll be lessons, there'll be theory, there'll be assignments, and there'll be demonstrations. And Farhan Zamir sir is a perfectionist. It's very difficult to catch hold of him. He's the Chief Scientific Officer of ALVA, renowned personality throughout the country, one of the best bioinformatician we have got. And to his students, they say he's a bioinformatician magician. Okay, so don't believe me, guys. I'll bring him up on the screen, talk to him, and you will truly believe that he is really a bioinformatician magician. He'll give you insights which you have never ever seen on any platform anywhere in this world. So let's begin this session. Dr. Farhan Zamir sir, welcome, and thank you so much for joining us.
Thank you, sir. Thank you, sir. Thank you, Shekhar sir. Thank you for having me today, sir. I'm good, sir. How are you, sir?
I'm doing great, sir. And today, finally, we are doing a live cohort together. That was my dream, one of my dream, to share screen with you, and that's finally happening.
After 1 year, sir. After 1 year.
Yeah, after a year, because of your busy schedule, my schedule, it was not able to fit in. But finally, for our students' sake, we are here. So, sir, we have our students right here, and let's start with the topic which we have: future, career, and scope of bioinformatics. What are your thoughts, sir, on this?
Sir, this is a $1 million question, and the answer is like an ocean. So we need to always touch drop by drop. So the question, and especially in bioinformatics, we work with one mantra, and the mantra is garbage in is garbage out. That is
right.
Only if we can have specific questions, only then the computer will give me specific answers. So in terms of bioinformatics, questions are called as queries, and the answer what the computer gives us is called as subject. So it is a communication between the query and the subject, sir. Now, coming on to the point, like what is the scope? Sir, scope is infinity, square plus one, sir. So it is that is the amount of scope what bioinformatics has. So how do I start? Because sir, if I decipher bioinformatics on a basic platform, bioinformatics specially requires on a default mode you should be a biologist, sir. Okay, you should
Mhm.
you should know thorough knowledge of biologist. Only then you can apply the laws of computers in analyzing biology. So you cannot
Mhm.
sit in the front of computer and then start thinking about your biology. So whenever I sit in front of my computer on a default mode, I know that I know the basics of genomics, I know the basics of transcriptomics, I know the basics of proteomics, I know the basics of metabolomics, and I know the basics of epigenetics. So with all these as a central dogma, whatever we studied at the both classical dogma and modern dogma, okay, I should know in thorough, okay, the basis of the biology, and only when I know this I can move forward, sir. Let me try to give you a very quick example, sir. I,
Mhm.
sir, now you are sitting in front of me. I will try to take one cell from your body, sir. You have epidermal cell, and from your one cell, I will try to extract a DNA. When I extract
Mhm.
a DNA in that one cell of your body, that is the epidermal cell of your body, I have 2 meters of DNA, sir. So you can just imagine in that one minute cell, I have approximately a 2 meters of DNA. Now you may need
Mhm.
to appreciate the nature that this 2 meter of DNA is so complexly wound in such a way that all the secrets of life, okay, we call it as the secrets of biology, these have been coded in that particular 2 meters. So this, it could be either ATGC, 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 or it could be my fatty acids, or it could be my 20 amino acids, or it would be my nucleotides, or it would be my carbohydrate moieties. So all these
Right.
in is in this particular 2 meters, sir. Now, if you can just imagine that if I am isolating all the DNA, because you are made up of billions of cells, okay, and
Of
if
course.
I isolate these DNA from the billions of cells in your body and then attach as 2 meter, 2 meter, 2 meter, 2 meter, you can just imagine the length of DNA which is just
Mhm.
present in Shekhar Suman, sir. And for your
Right.
surprise, sir, I can keep the Mother Earth, the planet Earth at the center. And if I take this as a thread, I can go by around 2.5 times around the circumference of the planet Earth. So that is the huge amount of data. Now, once I have the oracity of data, again,
Mhm.
to read this 2 meter of data, which contains just in terms of genomics, if I say it is just ATGC, ATGC, ATGC. So if I
Right.
just display it on a projector, and if I tell you to just read it, okay, this just for ATGC, 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 can you imagine what would be the time taken, sir? Approximate
Huge.
time taken.
It should
Okay,
be huge long time, I'm sure, right?
obviously, right, sir. Sir, it would take around 180 years
Oh my God.
to read your 2 meter DNA. Sir, I'm
Right.
please pay attention to read your
Yeah.
2 meter DNA, not to understand your 2 meter DNA. To read your
Just to
two
read.
meter DNA, ATGC without any meaning. You're just day in
Okay.
and day out, you're just reading ATGC, and it would take 180 years. Which
Oh my.
implies now if by any point of time a human lifespan is around 60 years, this means to say you need to reborn thrice to
Three
read
times.
your ATGC. Now, how about understanding it?
Forget it. That's
That's
too much.
that's the question, sir. And here
Wow.
and here comes the role of computers, sir. Now,
Right.
whatever was being done, what you took around 180 years to just read it, but computers
Mhm.
can do it in 1 nanosecond.
Awesome.
And that is
That's
why we
correct.
need to. That is why we need bioinformatics. That is why we need computer science in biology, sir.
Right. So humans are complicated, supercomputers. To understand humans, we need computers. Right.
Obviously, sir.
The
Absolutely.
Yeah. Wow. Great. So that's a great insight from you, sir. So I would encourage the audience also to ask some questions to sir, because this is a informal Q&A session. Whatever questions you might have, sir is right here, and he comes very rarely live, so you can ask your question. And so, sir, what are its applications of bioinformatics now in biological sciences, and does a regular biologist require to study bioinformatics?
Obviously,
What's
sir.
your take?
Sir, initially, like 20, 30 years ago, it
Mhm.
was only pure science. Now, after the advent of everything, the pure science it got translated into applied science. Now, applied science has got translated into allied sciences. Now, allied sciences has got translated into interdisciplinary and intradisciplinary sciences. And right now, we are in a juncture wherein we are into transdisciplinary sciences. So, sir, just one subject is simply not sufficient. People, and especially because when we talk to a lot of companies and when we talk to various kinds of research institute, nobody likes to have a proficiency in one subject, sir. They want a total package. Okay,
Of
and
course.
taking me as an example, basically I'm a biochemist, sir. But with my research it was mandate, because that was the necessity of that particular hour. And I'm talking about last 15 years back, when bioinformatics was just emerging. I had to learn bioinformatics. I would have not put in barrier saying that, oh, I am a biochemist and I don't want to learn computers. And right at that
Okay.
point of time, it was a bit hard, but all the fruits are being ripened over the period of time. And I would also say that's a major reason that Biotechnica was also able to identify and give me an opportunity and a platform, sir. If I was just a biochemist, then I would have been out of the market, sir.
Right. So if we want to stay future proof, future compatible with the ever evolving biological sciences market, we must pursue bioinformatics. So that's a great message from Farhan Zamir sir there. Thank you so much, sir, for that. Now we are getting some interesting questions. So let me bring up the question. So we have a question from interesting name Be Late. Okay. And his
Okay.
question is, what are the career opportunities in immunoinformatics for someone who has done BTech in biotech?
Okay. So the be late. We need to change it, because if you are late, okay, you will miss the train, sir. Okay, so no, relaxing and be late is not the mantra. You need to grab the opportunity, sir. And opportunity only knocks once. So we need to be on time at the right place. That's the fun part of that particular tagline. But however, moving on forward with immunoinformatics. So this is again a beautiful branch of bioinformatics. That's the reason I told you that bioinformatics is a big ocean. Now, the
Mhm.
way you actually elude it for the application part of it, okay, that matters. Now, as I was trying to, this person like Belate has actually asked a very good question. The question is, he is trying to use bioinformatics for the benefit of understanding immunology.
Right. Mhm.
Okay, so this branch of bioinformatics is called as immunoinformatics, or immunity hyphen informatics. So here people are trying to understand what are the immunological responses. Okay, and how do I stimulate the same kind of an effect using computers? And especially, sir, COVID has taught us a lot of lessons. Every day there was some mutation. Every day there was some new spike protein which was getting mutated, and understanding this at the core, bioinformatics is one of the key mantra which could be sir, a tool which could analyze immunoinformatics. And in terms of scope, we have a lot of scope, right from vaccine development, either it would be wet lab, dry lab, post research, pre research, okay, experimental research, meta-analysis. All these comes under immunoinformatics. So you learn the platform of bioinformatics, and you can apply the formula wherever you want, sir. So it is simply like it is learning cooking. So
Right.
you have the rice, it's the same rice, but on the
Uh,
way you need to know whether that rice is going for a biryani, or that rice is going for a curd rice, or that rice is going for a lemon rice,
that
because
is
the end
correct.
product, the final presentation will be different, but the
Correct.
formula, the permutation combination will be still the same, sir. So immunoinformatics has huge amount of scope, especially in understanding the antigen antibody interaction, and especially b cell therapy and T cell therapy are booming up, especially in terms of
Mhm.
cancer. Okay, so T
Right.
cell therapy is one of the major and promising therapy wherein people are relying on, especially for brain tumors, for breast cancer treatment and all these things. So immunoinformatics would be of a huge boom, sir.
Wonderful, wonderful. That's a great insight by Farhan Zamir sir, as you can see, guys. So I hope be late. You got your answer, and don't be late. All right. Now coming to the fact here, I wanted to highlight because I'm getting a lot of questions. About the starting salary of a bioinformatician and all that. So I think you should not look at that. However, I'll answer that question. But you have to look at the growth part. because you always have to start from A, and A always is discouraging. Okay, but when you proceed forward, you will realize, like sir said, if he didn't knew bioinformatics, he would have been incompatible with the market. But today he is getting projects and grants back to back from various departments of government also, just because he is a bioinformatician along with a biochemist. So that's what is helping him. All right, so now I have a personal question, sir. So let's start with how exactly the history is, like how far how it has impacted the biological research. Bioinformatics has impacted the biological research in what ways? Can you please throw some light on that, sir?
Great question, sir. Sir, it all started with the evolution of science. And just to remind you, sir, science was a secret from time immemorial. Aristotle, he did some science. Socrates, he did some science. Pluto, he did some science. But the science was so secret that only the knowledge was being transferred from the master to his own disciples. So only it was, most of the times it was a trust issue. Now, in the
Right.
same way, people were trying to document it, and by some other incidents, if that documents were lost, or it was by, with an accident like fire or water, floods, etc., then the whole document, the whole entire research was gone. Now, it was in 1984, the senator of US, he thought, Venter. Okay, so he thought that why don't we actually put up a platform wherein at least people in US have an advantage of utilizing the data, and that is how the greatest database, or the greatest institute was created, and that institute is called as NIH, National Institute of Health, which is at Bethesda, USA. And they thought, okay, we will try to focus on medicine and health, but there is a specific requirement wherein we need to store data, and that is how the first and the largest database of biological system evolved, and that database is your NCBI, National Center for Biotechnology Information, was developed because of this particular requirement, sir. And then the next component was, the US government was only funding the scientists at US. Then the other country, especially the EU people, thought, if US have developed this kind of a database, let us try to also develop this. And then the next country which was successful in developing this database was EU, that is the European Union, and they built this particular huge database which was called as EMBL, European Molecular Biology Laboratory. And the third and very important database was developed by Japanese, which is called a DDBJ, that is DNA Data Bank of Japan. And currently the fourth highest or the biggest database is from Switzerland, which is called the Swiss Institute of Bioinformatics. Now, sir, it feels very pity. It feels very pity, and it feels sad. In the last 20 years, we are just relying on data from other countries. But in India, we have not launched anything. Okay, something like an NCBI or DDBJ. We directly rely on the other countries' data, and we use it, sir. So my dream is one day, all our students, they come together and develop an institute. They develop an a proprietary wherein they can actually deposit data, because the entire world seeks the data from India. But we right now we don't have any platform which can cater to this, sir.
And we have the biggest gene pool, biggest population, biggest data generation capacity.
Sir, you name anything, everything is big. The only thing is we are lazy, sir.
No, I think, to some extent laziness, but to some extent, one more thing I would like to add here, sir, is we need more bioinformaticians in India.
Obviously, yes, sir. Obviously, yes.
Any community grows when there are more members in that. So the more number of bioinformaticians and biologists who are bioinformaticians, definitely demand will be higher, and that
very
will
true,
happen.
Sir. We need to also blame the education system, sir. In India, education system is it is like unidirectional. Okay, you do you do biochemistry, you will only study biochemistry. You do chemistry, you will only study chemistry. There should be a bridging component. Okay, and wherein in this bridging component, we should be able to amalgamate different kinds of life science. Example, mechanical engineering in biology. So wherein how do I understand, sir? I had an intern. Her name is Azad. So she was a mechanical engineer, and at Biotechnica she was able to learn bioinformatics, and with her as an input, she says that now she can do more amount of mechanical. She understands mechanical engineering. in not just in terms of mechanical engineering, but it is called as biomechanics. So now she's applying the laws of mechanics onto biological unit, that is onto the biomolecules, and then she is trying to explore the biomolecules. An excellent girl, an excellent student to talk about.
Wonderful. So you can see that the mechanical engineer is learning bioinformatics. That's great.
Obviously.
Okay, so sir, in the middle of this, we have a lot of questions coming in. So let's talk about the next question after be late, and let's not be late. So Akshaya Panir has a question. I'm studying BSc Honors Biomedical Science now. If I take up biotechnology elective in 4th year, can I do bioinformatics in MSc? Sir, over to you.
Yes, sir. Yes, sir. The answer is yes. It is not just one, biomedical engineering. You have been eligible to do, you are eligible to take bioinformatics, MSc in bioinformatics, provided you have a basic BSc degree in any life sciences, in any subjects in life sciences. So you are eligible, sir. Absolutely no issues.
Okay. So the next question, I think I would like to come in here and answer. So the question is, how much is the starting salary of a fresher after passing just MSc? It starts somewhere around 25,000 rupees per month, and it goes up to 50,000 also, depending on your talency, qualification, certification, internship, hands-on, and various other parameters, including your leadership skills, team building skills, communication skills, and a lot of interpersonal personal skills. But now coming to bioinformatics, definitely it becomes better because now you have an added skill set. So I think that answers your question, Nikita. Sir, you would like to add something here?
Sir, in normally in Kannada there is a proverb saying that talage bele. Okay, now what is this talage bele? Whatever you have, because in corporate sector nobody is looking for your marks, sir. Just to tell you, sir, I am not to blow my own bugle. I'm a first rank student throughout my career, sir. Okay, first rank, gold medal, all these things. But you'll be surprised to know nobody has looked into my marks card. Nobody has looked into my gold medal when they were offering me a job, sir. Okay, so it is basically how much can I contribute, and that contribution comes with how much did I update myself. Okay, and especially if I would have stuck up with my MSc biochemistry or PhD biochemistry, this would have not been possible, sir. I was able to take up lot of internships. At that point of time, my parents were thinking that this guy is just studying, and for some reason he's not qualifying. Okay, because every time when they asked me, I said that I'm studying. Okay, there was a granny, my granny, and she was like, she said, this time I will pray that next time you will pass. Because one or the other day, I was just taking internship. I was getting trained from various other people. So that is how, sir, adding on internship, adding on certifications will give a fruit on a long-term basis, sir.
Right. So that's where I think I should add one more line, sir. Play long-term games with long-term people. That's how you grow in life.
Absolutely.
I hope that answered the question, Nikita Maurya, right? Okay. So next question is from Anand Kumar. So Anand asks, other than Python lag, is it important to learn Java also for bioinformatics?
Okay. Sir, right now we are communicating in English. And you are talking to me, and I am listening to you, and I am talking to you, and you are listening. Suddenly, if I start talking in German, or if I start talking in Latin, okay, so you will not be able to understand. There would be a communication gap. All this, like Python, Java, C, C++, various. These are just the modes of communication, sir. The important component, what we need to understand is, one language is sufficient for me to communicate with you. So for me to communicate with you, I don't require 10 different languages. So if I am proficient with only one language, which you are able to understand in this term, okay, if computer is able to understand, for me, only one language is sufficient. And especially with my previous experience, I would always recommend Python. Okay, if you are a biologist, and if you are trying to learn coding, start with Python. Okay, and Python gives you a lot of huge amount of community, which will be always there for your assistance. And many times it will try to help you, understanding bugging and debugging of the code. And the syntax and other things are very, very easy than compared to other languages. So if you are a biologist and then trying to understand, coding, then I would always start with Python, and I will make sure that at least I will spend around 3 to 5 years in upgrading with that of Python, rather than putting my hands in various dishes. Okay, I will try to upgrade in Python. Okay, because just one language is sufficient to understand biology. Now, if you really want to have various systems, you can still go on to Java, C, C++, other things, but you should always know what is your requirement.
Right. So that's a great insight from Prohan Zamir sir. So as you guys learned it, one language is sufficient, and Python is easier for a biologist to understand because it's plain English. So it's very easy. In fact, I have learned it, so it's very easy. You can do it. If I can do it, you can do it. Okay, so let's move on to the next question. We have a question, an interesting one, and I think challenging one probably. Bhavna Arora, and she asks, "Hello, sir. We are trying to figure out a mechanism of a disease which is not deeply studied. What can be a bioinformatics route to study the pathophysiology?"
Sir, the direct answer is, she has to take an internship, wherein at Biotechnica, wherein you have designed a beautiful course that is the Biotechnica Global Tools and Techniques. Okay, which is actually based on this. Okay, but anyways, just to answer this question, this is a huge question, sir, because it's a broad question. So first, I need to understand the story. The story says, when you say a disease, which disease are you talking about? Because in bioinformatics, as I was trying to tell you, garbage in is garbage out. I give a garbage question, I give a garbage query, the computer will just give me a garbage answer. So I need to be very, very specific. So I need to know what is the disease. Okay, if I just say cancer, that is not sufficient, sir. I need to tell, what pattern of cancer, because cancer, again, I can tell in terms of breast cancer. Okay, now again, breast cancer, whether it is because of the habit or habitat. Okay, and then gender specific. Now you'll be surprised to know, female breast cancer is treatable, sir. Female breast cancer is treatable, and the prevalence of male breast cancer in India is actually increasing. And male breast cancer is only detectable at stage 4, whereas female breast cancer is be detected at stage 2. So the chances of me giving chemotherapy or radiation therapy for a female becomes much more easier. But in males, the detection itself is at stage 4. By the time I give chemotherapy and other things, all my immunological cells and other things have been already invaded. Okay, and then I become immunocompromised. So, hence, I need to know what exactly is the mechanism. So, one, I need to know my disease. Second, what mechanism are you looking into? Okay, when you say about pathophysiology, first thing what I need to understand is I need to also understand what is the normophysiology. Only when I understand the normophysiology, then I can correlate it with the pathophysiology. What is normal and what is abnormal? Okay, again, in abnormal, there is higher, there is lower. So we call it as hyper and hypo. So again, I need whether am I looking into hyper condition or am I looking into hypo condition? So this is also a very important component what we need to look into, sir. And then very specifically, we need to look for specific targets, bio targets. What are you targeting? Okay, so in bioinformatics, we can have various approaches. You can go with a genomic approach, where in example you can target the MAP kinase, or you can target the BRCA1 or BCL2, something these kind of genes. Now, if you do not want to target this kind of a genes at the raw material stage, okay, you can target them at the end product, which because these genes they produce protein. So I can target the protein component. So it becomes, or the metabolites, if you're targeting the metabolites. So when you're asking a question and when you're trying to design your research hypothesis, we need to be extraordinarily precise. Being accurate is not sufficient. We need to be precise. And the answer is yes, using bioinformatics. Okay, we can actually understand where exactly your drug can actually work. Okay, under a given condition, and hence mode of action or mechanism of action could be eluded using bioinformatics.
Wonderful. That's a very detailed answer, Bhavna. I guess you got your answer. So, students, we are having limited time, so quickly put in your questions because otherwise we'll miss it out. Okay. Now, coming to the fact which Sir said initially, yes, we're going to run an internship from 15th of February, and that will be done by Sir himself, and he will be taking all this in detail. And in fact, he's going to teach you more than 20 plus softwares, all open source. You can practice at home. You can do hands-on training of all of it. Hands-on demonstration as well as training will be there. Assignments will be there. You'll be able to practice it in a real way, and then you'll be good to go to any lab and apply it. So that's a great, amazing thing which is coming up. That's called Bioinformatics Global Tools and Techniques Hands-on Train Internship. Now, our next question, coincidentally, is the same: that what can be the internship programs and what are the skills required? So, sir, over to you.
Sir, normally for the internship program, the skill required is, if you at least know a small amount of biology, okay, that is sufficient for us to make you teach bioinformatics. And when we teach at Biotechnica, we make sure we do not directly jump the ladder. We go from, if you look into the modules, the first 1 or 2 modules is to brush up your basics. Okay, once we brush up the basics, the foundation is laid. And once we lay the foundation, then we start building up the walls. Okay, and finally the roof. And that is how we actually train our internship. If you look into our feedback from our previous students, they are like so happy, so satisfied. And sir, you will be surprised to know, because I know that you are like super busy, but you'll be surprised to know people who have attended our internships, they were able to publish research papers in good journals, sir. In Scopus Index journals, in Web of Science Index journals, they were able to publish their data. So whatever learning that was being implicated onto their research work, and they were able to come up with the good amount of manuscript. And many a times they say that, sir, for doing any bioinformatic data, I don't require water, I don't require distilled water, I don't require chemicals, I don't require test tubes, I don't require append of tubes, I don't require pipettes. Okay, without anything, I am able to, whatever I can imagine, I'm able to translate onto the computer, and the students feel so happy. And looking at them, so being so happy, I feel so contented, sir.
Right, and that's really great that if we are able to achieve this kind of results, credible results, by just using our software skills, it's amazing. And hats off to you, sir. Your patience and your way of teaching is amazing and marvelous. I think if I was a student, I would have become a bioinformatician if I had a teacher like you. You are seriously architect of our students.
Sir.
And
thank you
so
and
much.
thanks to all my students, sir. Thanks to all my students. They are so patient enough, okay, learning things, and especially it was like online, and will make sure that we have absolutely no difference between an online class and an offline class. Okay, and normally we always have a communication. It's a two-way communication, and whenever we are trying to demonstrate a tool or a software or a package, students, they directly ask questions. So the doubts are not being carried out onto the last 10 minutes or Q&A session. The doubts have been clarified then and there itself, sir.
I hope all of you can see here. I was just showing a testimonial from one of the students. Let me just, for all of you, I hope you are able to hear it now, see it now. So if you can see, this is one of the feedback which a student wrote for Hans Amir sir, that he's got an opportunity in computational biology in RGCB thanks to the bioinformatics, and which he used to think scary, like coding is scary, but now it's not. So you can see that's a great magic done by our very own Farhan Zamir sir. Now let's move on to the next question, sir. We have our next question, I guess, from Loga Lakshmi. Let me just pull out the question for you, sir.
Loga Lakshmi is my own student, so I remember Loga Lakshmi, sir.
Okay, wow, great. So yes. Loga Lakshmi is here, right here again to interact with you. Currently, I'm doing project in miRNA, interaction with mRNA. And is it possible to show the interaction in bioinformatics?
Yeah. Sir, for this, one, we can use Python. Okay. And the second component, we can also use Cytoscape for understanding, the interaction. And there's a beautiful tool which is on QIAGEN, database. Okay, so QIAGEN is it's a company, and this company actually gives a demo version of understanding the miRNA interaction, and this is called as Ingenuity. So Ingenuity 2.0 is one of the beautiful software which is helping in understanding and developing the networks with the miRNA of mRNA interaction, sir. This could be done, sir. This could be done.
Wonderful. So I hope that answers your question, Loga Lakshmi. Let's quickly move on to the next one, which we have from Lakshmi Balasubramaniam. What is the scope of doing PhD in the field of brain and artificial intelligence, and how much of coding knowledge of bioinformatics knowledge is necessary for working in the same? Wow.
Obviously, that's great. Sir. Now there are three components in this question, sir. The first component is neurology. Okay, so yes, if Lakshmi madam is looking for brain research, I would always suggest her to go into the institutes of national importance like AIMS or Nimhans at Bangalore. Okay, these are the pioneer peoples were doing hardcore research in neurology. So this is one
Right.
component. Uh, Once we
Right.
understand the neurological components of it, now AI, that is artificial intelligence, can take over, because until now our imagination of a brain was very very little. Now using the applications of AI, we can open up the huge horizon of neurology, so that people can understand neurology at a next level, sir. So yes, obviously it would be a very good research if you are able to apply AI with neurology, or
Mhm.
with brain sciences or brain research. Let me try to give you a very short example. Sir, when we do craniotomy is, people when they have meningitis, okay, when they're brain dead, or there is some block and other things, hemorrhage and other things. So what we do is we do a process which is called as craniotomy. Craniotomy is we open up the skull. Okay, we open up the skull, and then we have micro injections. We can inject injections directly into your brain, into the cranium, and that is how procedures have been done. But the
Right.
problem here is the patient is unconscious. Okay, the patient is unconscious for the next 3 days or next 5 days after craniotomy. Now,
Mhm.
can you imagine? I'm trying to tell you, the patient is unconscious and not dead, okay, or he's not in a coma. So under this unconscious condition, the patient is not able to express pain, because
Mhm.
your head is open. Okay, so there is a huge amount of pain, but in no way in neurology we are able to tell what is the amount of pain which has been suffered by that patient.
Right.
Okay,
Right.
now using artificial intelligence, this could be done. This is called as pain charting. You chart the
Of course.
pain. Okay, you chart the pain. So once this has been done, depending on your AI algorithms, you are able to chart pain, and then oh, this person is having this much of quantum of pain. I should give this kind of a drug. Right now,
Right.
whether you are suffering pain or you are not suffering pain, a general protocol has been just followed, sir. Now if
Right.
like researchers like Lakshmi madam, if she can come up with these kind of ideas, wherein if she can amalgamate AI with that of brain research, excellent idea, sir, excellent idea.
That's a
Okay, so this
brilliant
is the,
idea.
yeah, this is the next component. And then how do we do it? Because finally, when I say that I want to measure pain, but how do you do it? For
Hmm.
doing this, you need to have targets.
Right.
You need to have targets, excuse me. So you need to
Right.
have targets. And what are these targets? These are your bio targets. How do you select your bio targets? For selecting your bio targets, you require bioinformatics. So yes, you can put up the three triangles, the three corners of the triangle, that is the brain sciences, then the artificial intelligence and bioinformatics, all put together. Okay, sir, I have actually termed this particular terminology. This is called as neuropathogonomics.
Wow. Yeah.
Okay,
I think we were
neuropathogonomics,
already
wherein we
get
study
on.
neurology, we study pathology of a given condition. Because I am a gut biologist, so we
Right.
study the gut, and with what tools we use omic approaches. So hence it is called a neuropathogonomics. So
Right.
a beautiful chapter from our research team has been published by Elsevier, and this is
Mhm.
called a synthetic biology. Okay, so I would
Right.
always request Lakshmi madam to go and read that particular article, which talks about the gatomics and putting up various fields together to emerge into a newer idea, sir.
You are right. And
Lakshmi madam,
I
it's
think,
an excellent idea. I'm so excited with this idea.
yeah, and there's a commercial application of this in the blood-brain barrier. When was uh, this Neuralink comes up with this computer-brain interface? Sorry,
Correct.
the computer-brain interface. That is where its application will be. Okay, without wasting much
Sir,
time, let's
sir,
come.
Neuralink. When you say Neuralink, everybody talks about Tesla, Elon Musk, but people have forgotten the same Elon Musk has put up a lot of money in Neuralink. Okay, wherein he is trying to develop algorithms which can understand brain. Because once you
Right.
understand brain, everything has been under control, sir. So
Correct.
even people are now trying to understand, develop AI algorithms for malls. Okay, so the moment you enter into a mall, the AI algorithm will read your face, okay, and it
Mhm.
will decide whether you are come into the mall for window shopping, or whether you are your requirement, if there is a specific requirement. So just
Okay.
looking into your even the footsteps, what you come inside, into the mall, it will decide what is the urgency. of your fetching up the product. So there are a lot of algorithms, a lot of new apps which have been developed. So Lakshmi madam, you need to work on this.
Great idea, sir. There. So we have one next question from Nikita Maurya. Your thoughts on freelancing in bioinformatics, and which is a highly paid skill in bioinformatics?
Okay. Again, there is nothing called as sir. Where people, when they are looking for money, they should also see what they can offer. So, sir, it is a simple mantra. If I am asking for around 10,000 rupees, that means to say I should be able to contribute 10 times more. So the data what I generate should be at least 10 times more. So the data should worth around 1 lakh rupees. Okay, so only then people outside they are also intelligent. So how exactly with your knowledge, okay, how exactly you are able to satisfy your customer, and the customer appreciation becomes more very much important. And depending on that, all your salaries and other things will go on hike, sir. So at the initial point itself, if I'm talking about money, okay, so I'm just stuck there. I'm just stuck.
Right.
So I request everybody. Because bioinformatics is so dynamic subject. Every day, sir, I cannot say that I know everything about bioinformatics. I would always say I have 0.0001% knowledge of bioinformatics, because the moment we spoke now, something new in bioinformatics has come up, which I am not aware of. Okay,
right.
so hence, rather than looking at the packages, you need to first prove that what exactly you are capable of. And whenever it comes for freelancing, bioinformatics has huge scope for freelancing, sir. Okay, there are a lot of companies, especially we need to focus on three major sectors until the entire human race. Okay, these three sectors will never die. The first sector is the food sector, sir. Can I use bioinformatics in food? So until I am alive, I need to eat my food. So I require bioinformatics for this. And you will be surprised to know bioinformatics in agriculture. Okay, these are the new booming subjects which are coming up. Now, once I am living and once I'm eating food, then obviously, because I will eat whatever I want, then I will be suffering with diseases. So if I'm suffering with diseases, I need to have drugs. So hence, the next important sector which will flourish forever is pharmaceuticals. So how do I apply bioinformatics in pharmaceuticals? This is the second important thing. Sir, when I am alive, when I'm eating food, and when I have no diseases, then I want to look better, sir. I want to look good to my people. Okay, and hence cosmetics will come into the picture. So food, pharma, and cosmetics are the three major streams which will never die, and this could be enriched using the knowledge of bioinformatics. So I would always suggest my students to look into these three core areas, because this is this until the human race, these three subjects will be always there, and the scope will be always there, sir.
Great insights there, sir. Thank you so much. I would like to add one more line, because I have experience of the commercial aspects of bioinformatics. So when you have bioinformatics knowledge, you can easily help companies and become a consultant, help companies analyze with large chunks of data and charge for it. You can also maintain databases which you can sell to other companies. So there are a lot of scopes there, and like sir said, pharmaceuticals, food, and cosmetics, it's never going to die down. So now quickly moving on to the next question, which we have from Pooja Huda, and that is it important to learn all the languages in bioinformatics, or can we just make ourselves better only in Python? I think you have already answered that. Only Python is sufficient.
Right? So not just we are not just promoting Python. What I am trying to tell you is, any one language is sufficient, sir.
Yeah,
it's not any one language is sufficient.
Okay. Next question by Alok Bhardwaj. It is always so informative to listen to Zamir sir. He delivers same thing in an interesting way. Wow, that's a great compliment. Thank you, Alok. Next one, I'm doing BSc Biotechnology. So how can I start my career in the field of bioinformatics? Bhumika Jangir. Sir, over to you.
Okay. Bhumika madam, since you have finished your BSc in bioinformatics, you can start, if you want to think about your career. So I would always request you to do your masters. Don't directly jump into a career soon after your BSc. It is not that you cannot do it. You can still do it, but the packages, the salary packages which will be offered will be lesser. So I would always request you to pursue a master's in bioinformatics and then go to a company or then start your career. That will actually enrich your knowledge, and people in the market will also respect you because you have a strong foundation in biology, and that could be encashed in a company or a corporate sector. So I would always request you to pursue your masters and then start your career. Now, inevitably, if you want, desperately, due to certain financial issues, if you really want a job, then absolutely no problem. You always have a job, and initially around 15 to 20,000 is the package. But once you are trained for around 6 months in a given company, then you can always have a hike. So there is always a requirement, especially for data curation, bioinformatic data curation in most of the pharma companies.
Right. Let's move on to the next question, sir, from Uma Shankar, and that is, I'm an MSc Biochemistry postgraduate. I want to make a career in Bioinformatics or proteomics. How to initiate the process?
Okay. Just start applying the laws of biochemistry and amalgamate with bioinformatics, and then sir, either it should be with Uma Shankar is trying to go into a company or into an R&D institute, or if he is trying to pursue his PhD, this particular sector will matter. So any point of time, if he is just interested in doing it, obviously you can start. It doesn't matter whether it is genomics or proteomics, because you are looking at the window from inside out or outside in. So it's the same, bottom up or top bottom. So it should not matter. So you can always pursue your career in bioinformatics.
All right.
But
And
keep upgrading, keep upgrading. That's the only mantra. Keep upgrading. Do not be lethargic. Grab all the opportunities, whatever you get, and keep upgrading.
Wonderful. So another piece of advice from my side, if you are free, you can always do the internship, which sir is about to undertake from 15th of Feb. That will be a definitely good initiator and good starter for your career in bioinformatics or genomics or proteomics, because it encompasses all of them. All right, sir. Now next question quickly is Shreya Yadav. Currently, I'm pursuing BSc Biotech. How can I make a career in bioinformatics, and what can I learn from this field? This is a repeat question, sir. So quickly, if you could answer it.
Yes, sir. So, that depends on what exactly they are looking for. But, I would always say bioinformatics is a very, very lucrative, field. So the amount of knowledge what you have, if you are able to dissipate, if you are able to, reproduce it and give a meaning, so that the other people can actually relate to it, then, you have n number of opportunities, sir.
Right. So the next question is from Sagarika, and I would like to jump in, sir, 1 minute. The question says, BSc Biotechnology, I want to learn bioinformatics, but I'm fearful of working with computers. My answer is face your fear.
Now, डर के आगे जीत है, sir.
डर के आगे जीत है. Face your fear. Over to you, sir. You want to answer something? Add something?
Yeah, sir. This is, sir. Sagarika madam, what she is saying was also a fear of mine, like 15 years back, sir. So I would not say that this is abnormal. This is absolutely normal, sir. Because as biologist, I am computer illiterate. Technically, I am a computer illiterate. So when I am working on a computer, when computer is trying to tell me a command, okay, it gives me two options, yes or no. Okay, if I press yes, if that goes on, I'm happy. If it does not go on, the next option is I will press no. Okay, because right. I don't know what exactly is the computer trying to communicate with me. Okay, so right. It is absolutely normal to get scared, to get tensed with the computer. But once you become a friend to the computer, once you are able to translate your biology into the computer language, okay, you will feel that computer is one of the best friends. So this is how, sir, when we enter into a college, first day we have fear because we don't know anybody in the class. Okay, and right. The last day when we finish the course, everybody are our friend, and we don't want to leave our friends. So that's the same logic. There is absolutely nothing to worry, and I am sure, sir, in this particular internship, okay, if Sagarika madam, she is able to enroll it, okay, I am sure that in this 21 days, I promise that Sagarika madam will actually get out of the sphere of computers, sir.
Right. So that answers your question, Sagarika. Next question is from Naira Lohan. Interesting question. I took admission in PhD molecular biology and biotechnology. How can I make use of bioinformatics for my PhD research? Is Python R programming useful for me? Over to you, sir.
Obviously, yes, sir. So because molecular biology works with the prediction of bioinformatics. So when you're talking about molecular biology, you cannot look molecular biology separate and bioinformatics separate. Obviously, you need to learn bioinformatics and apply the rules of bioinformatics in your research work. Now, coming on to the Python and R programming, is it useful? Obviously, yes. Now, when you're talking about molecular biology, I also want to understand what is the veracity of your data. Now, if you're just running some gels, and if you're doing some small amount of cloning, then you do not require high-end bioinformatics. But on the or R programming also. But if you're working with a big data, now somebody was talking about miRNA and mRNA association, epigenetic studies, microbiome studies, big data analysis, then obviously R is one major program which will actually help you, and it's an open source and it's an easy. Shekhar sir, I want you to highlight on the an internship on the coding for biologist. Okay, because that's a beautiful course wherein people who do not know R, if they are not proficient in R or Python, they will be able to actually talk about it, sir. So over to you, sir.
Yeah, absolutely. So that's a point which I wanted to make from a long time now. Coding for biologist internship is also starting at the similar time. You can always go for these two internship, and it is going to really help you. And there's no harm in knowing these languages as long as you want to know the computer side of biology and you want to amalgamate both to grow in your career. Both are amazing internships, and you can take advantage of that. And they're coming at a very, very low cost at this juncture. So yeah, you can always go for that. So next question we have from G Padmaja, and she's asking, I'm MSc Biorechnology, pass out learning skills from bioinformatics would be enough to fetch a job, or else I have to do a professional degree? Over to you, sir.
Okay, sir, there is no necessity of doing another degree, because adding up of degrees will absolutely not help, sir. So, I would always require Padmaja madam to take up certain internship programs, to take on certain, certification programs, which will upgrade. You already have a degree. You already have an MSc degree. So beyond that, again having another degree, until unless it is a PhD, okay, having another degree will not help. Let us try to move on. Now, how do you move on? By adding up small blocks, okay, which can support your major degree. So with the help of your MSc Biotechnology, try to pursue additional certification courses, internship courses. Please remember, when you're pursuing this internship courses or certification courses, you are actually saving time. Okay, what you can learn in 3 years, what you can learn in 2 years, you can learn it in 15 days, or you can learn it in 1 month, which will actually satisfy the requirement of the entire thing. So I would not require, I would always request our students not to waste 2 years, because in this 2 years you are trying to build your competitors. Your juniors will be your contemporaries. So
Right.
Yeah, so in the next 2 years your juniors will also try to compete with you, and those 2 years of previous batches, they will also compete with you, and previously who passed with you, they will also try to compete with you. So the amount of competition will always increase. So I always request you to get upgraded with internships or certifications rather than thinking of a professional other degree.
That's a very important point and a great point, sir, there. And because your juniors will become your competitors, and that becomes more competition into the market, and I don't think you want that. So quickly, we have a question from Anand Kumar, sir, and that is, do I need to do, so he wants to do coding for biologist, and he wants to know, should I do a Python course separately? I don't think, Anand, you need to do that, because anyways, Python will be covered, right, sir?
Correct, sir.
So you
the Python will be covered in the same. So it is like two major concepts in one internship, sir. So one internship is sufficient, not necessary that he has to attend two.
Right. We have a compliment for you, sir, from Alok. Yes, he is a great teacher. Of course, we all are.
Thank you, Alok, sir. Thank you, Alok, sir.
Right. So, next question from Gargi. Can we work in both the field of bioinformatics and biotechnology?
Obviously, yes, sir. So these are like this is biotechnology is master. You have proficiency in everything, but mastery in nothing. So, but on the way, if you are trying to just elude the dry lab component of it, okay, and then try to develop concepts, that is your bioinformatics, sir. So I would always request people to look at bioinformatics not as one individual subject. Okay, you need to bring all the subjects together, all the life sciences, be it zoology, chemistry, even mathematics, physics. Okay, all these components could be brought into bioinformatics. And how do you use the laws of physics? How do you use the laws of mathematics in biology makes a difference. And once you start doing it, the kind of thinking itself will change, sir. You will be having much more broader thinking, and you will be having a moonshot view. of things, whatever you were seeing right, vertically or horizontally. Now you will be having a moonshot view so that you have a better vision and better insights. And that is the requirement of our society, and that is how we can. This is what I call it as Make in India, sir. Make in India is not just making products. At Biotechnica, I truly believe that this is Make in India, wherein Shekhar Suman sir is trying to build, okay, the
Human.
students who are our product, and this product, sir, today or tomorrow will not give you a fruit. This product, long term, 10 years, okay, will absolutely, you will be proud of all biotechnicals, sir, and I'm damn sure of it, sir.
Absolutely, sir. My students are our long-term investment, and that's how
Obviously.
we always look at our subscribers and students. And thank you so much, sir, for that compliment. So we have next question, sir. Quickly, last 5 minutes left. I'm learning Python and DSA while I'm doing bachelor's in biomedical. Is there any scope in the clinical setting?
Obviously, yes, sir. Obviously, yes. So nothing will go as a waste. Okay, just keep learning. Just keep learning. At the right opportunity, just try to combine things. Okay, when you combine
Right.
things, the new thing which will evolve. So there's no harm in learning, though they are into two different streams. But absolutely no issues. Let him learn, sir.
So Soumyadeep has another question, same person. Scope of clinical bioinformatics in diagnostic sector in future.
Huge, sir. Okay, and there's a very much, this is already trending in US and Europe. This branch of bioinformatics is called as pharmacogenomics. This is called
Yes.
as pharmacogenomics, and in pharmacogenomics, sir, you will be surprised to know people are now starting their sperm banks. People are starting their ova bank. People are starting their stem cell bank. Okay, umbilical cord stem cell bank. Okay, so what are they trying to do? Whenever they are, like, the moment they are born, okay, umbilical cord cells have been taken up and they have been deposited. Now, long term, okay, maybe 50 years, 40 years, if the liver is gone, imagine somebody, they have a, they are alcoholic and the liver is gone. Now, in that condition, okay, they can go back to their stem cells. They are able to retrieve their stem cells, grow the entire liver with 3D printing and scaffolding or tissue engineering, and again they can replace it back. The huge advantage is there is absolutely no graft rejection. Okay, your body knows that that was your cell, and there's absolutely no graft rejection. There's no point in you are waiting for a donor or so. Any part of your body or your organ system could be developed, and this is how you have a huge scope, especially in diagnostics. And coming on to pharmacogenomics, sir, whenever the baby has been born, the cells have been taken, DNA is isolated, and they will sequence it, and they will give you as a chip. Okay, now this has gone as fancy. This is like a status symbol. Okay, and this is going as a pendant. Okay, so this would
Right.
be your identity. Now, tomorrow, whenever somebody is sick, okay, the same person, again, it takes a whole genome sequencing is now taking 1.5 hours. So once they take up the sequence, now they are trying to compare the sick sequence with that of the healthy sequence, and now they know very, very precisely where exactly there is a problem. So this is a new branch. Okay, though Datta sir has asked a direct question, this itself is called as customized therapy or customized medicine, or it is also called as precision medicine. So gone are the days wherein I had one drug acting for multiple people. Now there is a concept wherein one drug, one person. So it is customized only for your body and not for others. So you have absolutely zero side effects. So that's how the application of clinical bioinformatics in diagnostics will be the future, sir. And sir, you'll be surprised to know all our diagnostic centers, like biochemical diagnostic centers, which are analyzing urine, blood, sputum, feces, everything will shut down one day, sir. Okay, they might be mad at me for telling this particular statement, but there will be only one concept wherein people will invest on sequencers, and with the sequencing technology you can tell whatever diseases a person has, and that would be much more precise, error proof. So that day will come, sir.
Right, right. And that day will come, and the prediction is right here in front of you guys. Here we have the next question, sir, and this will be the last question. And in the meanwhile, I have a special announcement for all the students before we take up this question. So all my dear subscribers, students, and fans of Biotechnica, you know this fact that Biotechnica is starting this amazing internship, and you met the trainer, the same person. Dr. Farhan Zamir sir is going to train you on this particular internship, and you are going to be amazed by the way he will take you to the depth of bioinformatics from basics to latest. All the fear will be gone in the snap of a finger, and you will realize that you have become a bioinformatics pro. I have learned it the harder way that it is not you who is weak, it's the teacher who makes you strong or weak. And you have a very strong teacher right in front of you. So, ladies and gentlemen, boys and girls, we have this amazing internship, which you can see on the screen right now. I hope you can see on your screen. Now, this particular internship, we are starting from 15th of this particular month, and it will be our very own Farhan Zamir sir who will be training all of you. Now, I request all of you to join it. There is a 50% discount running right now, which will change. Okay, and in the next 24 hours time, it will change back to 13,000 rupees, 13,995 rupees. So if you want to save money and enroll, please do that in the next 24 hours. And this particular internship is also available if in case you have less money and you will not be able to afford, we still have a subscription model where you can pay monthly and you can avail this internship. Even that is available and possible. So please go ahead and do that. And now coming to the last question, which we have here. And that question I'll display now. Sir, over to you. Would you like to answer this question? MSc Microbiology, currently in a biotech company, want to switch to dry lab.
Sir, obviously, yes. Obviously, this is possible. And many times, the pure sciences has become, very stagnant. Now, applying the laws of bioinformatics onto microbiology becomes very, very, competent. And there's an emerging trend which is called as microbiome. Everything, you have been defined by the microorganism what your body contains, and hence, you can always apply the laws of microbiology with bioinformatics, and that is how you can just, learn about newer diseases, newer diagnostic markers using microbiome analysis. And again, for that, Python and various internships and big data analysis is one of the prime requirement. And I wish all the very best for all the students to learn bioinformatics. I request them to upgrade themselves so that they will be relevant and employable for the next years to come, sir.
Thank you so much, sir, for that insightful talk and all the answers. Patiently, you answered everybody in a lot of detail. And now we have run out of time. I can see another 10 more.
Sir, you give me 5 hours, sir. We need to do this session for 5 hours so that all our students' doubts and other things has to be clarified, sir.
Certainly, sir. I am giving you the entire internship. Let everybody join there, and they can ask you any question. So that's
Thank you, sir.
You can do. And to all the students, we're sorry that we could not answer some of your questions. So you can meet up Farhan Zamir sir in the next internship, which he's conducting, and you can ask all your doubts face to face, just like how we talk in this video session. I and sir are talking the same way. In the internships, you will be able to unmute your mic and talk to sir directly and clarify all your doubts. You don't need to even type in chat. That's the kind of flexibility sir gives you. And he is going to teach you amazing stuff. And this particular internship is starting very, very soon. We are running out of seats. So if you have not enrolled, the links are given in the description, as you can check here in the chat box. Please go ahead and enroll. If you have any question, there is a chat box on this particular page, which is there, and you can directly chat with the admission counselor. Any doubts you can clarify. Coming to, if you want to be in touch with me and talk to me about anything, you can always write to me at shekhar@biotechnica.org, and I would love to take all your questions. I hope you enjoyed this session, and I'll see you soon in the next one. Thank you so much, sir, for your time.
Sir, thank you very much for the opportunity, sir. I'm always grateful to you, sir. Thank you very much, sir. Thank you.
We are grateful, sir. We are so grateful to you for having us, giving us the opportunity to conduct these internships along with your guidance. Thank you so much, sir. Thank you. So that was Dr. Farhan Zamir, sir, who is going to start in a short while from now. Next week, I guess it's going to start. Please enroll early and be in touch. I'll see you soon in our next Margdarshika series. Till the time, please take care. I'll see you soon. Bye-bye. Have a great day ahead.